Okay, good morning, good afternoon, good evening, whenever you are choosing to watch this version of our back to school night here. This is Mr. Jones and the overview of what we're going to be doing in Chemistry 2 here this year. Let me just start by introducing myself and give me a little background on me, since this is your first time with your children in my class. I have a degree in geophysics and structural geology from Rutgers. I have a master's degree in that. That's my gig. Chemistry is probably the third topic that I teach. And I have been teaching here this will be my 10th year here. I consider it one of my favorite parts of the year, getting to meet my new sophomores. I do not teach any freshmen, so your children are my young'uns. And one of the great perks and privileges of my job here is that I get to meet these kids here in this year, and then they will all come back to me for physics next year as juniors, and hopefully all of them will come back for my senior elective in geoastrophysics. And a lot of them do that, and I get to watch them grow up and start to turn into those young adult professionals that I see that they're going to be at some point. So it's a real thrill for me. I also am not only a mate's teacher here, I am a former parent. Both of my children went through this program, and since I'm the only physics teacher, I did have them both in my class for physics at the time. My son graduated in 2014, and he majored in pre-veterinary sciences at Rutgers and now works for Banfield Pet Hospitals, which is in Newark. Well, he works in Newark, Delaware. They're the vet's offices that work with Petco. And my daughter graduated in 2012, went to the University of Miami, got a master's degree in environmental engineering, went to Seattle after that for a year and a half and worked as a team leader for Earth Corps doing restoration work in Seattle. Miami to Seattle. I spend a lot of time on airplanes if I want to see my children, it seems. Now, she has just started, she's done about 6 months of her new, probably permanent job working with the EPA in Denver. She's a project, Superfund site project manager for the EPA Region 7 in Denver. So I've lived it. I know the sleepless nights, I know the tears, I know the frustrations. So when your kids are in crisis over something here at school, I urge them to talk to me. I hope I can help, because I do understand what is the deal here. So what I did on day one with them is I kind of just talk about what chemistry is. And I mean, honestly, this chemistry course kind of takes us even beyond what AP does in some ways. And the lab experience, which we're very, very much trying to preserve this year, is one of the biggest things about this. They will gain experiences that their peers out in the traditional high school simply will not. And on day one, I like to just spend it talking about what is physical science and how do we learn it. And I asked them these 3 questions. Typically, I'd ask them to do this on an index card that I leave with their name on their desk. Of course, this year I did it as a Google form, and that worked out. We discussed the answers that they gave us at the end here. But that last one as to why chemistry is important. One thing I try to do very much throughout all the classes I teach is emphasize how important science is and how many areas of research and career paths they may not be aware of, and help them get there, hopefully. So just some contact information here if you want to pause this and jot this down. The email, of course, that's pretty standard. I keep a remind account for each one of my classes so that, if they're working on homework over the weekend, I'm not sitting on my computer, maybe I'm watching football on Sunday, they have a question, I can answer it for them and not get off the couch, which is great. And then I will be posting most of the stuff to the Google Classroom as we go along, but if I forget, literally all of my material, I have so much stuff on this website here, the WordPress site. Everything they need will always be there as well. Okay. As far as what we're going to cover here, this is what the book has. I kind of broke it into 6 major areas. We usually don't get to organic and bio, and those 2 topics are entire year-long courses at most colleges. So we're focusing on getting done with this. We were a little behind last June because of the circumstances, so this is what we should end up covering, these topics here. I try to teach chemistry from kind of a physics perspective, and I love the fact that we start out with states and matter because, as I explained to the kids on day one, try to get them thinking of the universe in a beaker. Our chemistry experiments occur in little beakers and flasks, but they involve matter and energy. The universe is actually pretty simple. It's 4 forces that act on matter: gravity, electromagnetism, and then the strong and weak nuclear forces that govern the behavior of atomic nuclei. So each one of those forces has its own range of influence, and you throw protons, neutrons, and electrons out there, and the universe does the rest. And it's amazing the complexity that those 4 forces and stuff create. Let's see, trying to think what else I wanted to say here. I really appreciate teaching Chem 2 because Chem 1 there's a lot more memorization, a lot more tables, a lot more energy levels and orbitals and quantum numbers and stuff that's really, in a way, very abstract. And indeed, my 2 kids also struggle through that a little bit. Here in Chem 2, we're actually going to look at what happens when these molecules get together and react, and that's a bit more exciting. Again, I hope that they will go on into careers that, it's hard to avoid a career that does not involve chemistry. I find I'm asked very often what's my favorite thing to teach. And honestly, of course, it's geoastro, and particularly the astrophysics and the physics of stars and how they manufacture chemical elements. But a lot of the evidence, for example, for Earth science and the evidence that we have for the history of this planet and the story of the history of this planet comes from isotope analysis and chemical analysis of rocks, minerals, fossils, and atmospheric gases. Okay? So we always keep coming back to chemistry, and I try to emphasize the importance of chemistry in all the other sciences. I tend to keep, you see here, the grade breakdown is going to be pretty much the same. I don't really change much from the policies of Chem 1. The syllabus is the same syllabus. I don't feel that we should be changing anything between semesters and teachers in that. This one might change a little bit. Just a caveat here. Given the AB format, I'm not sure. I can't speak to this. I'm not certain about whether there will be midterms and or finals. I have to imagine there will be some kind of final. It's possible that if we don't have midterms, this 10% might just get amalgamated into the other 2 marking periods. I honestly don't know. We will see as things go by. All right. So why is chemistry important? I got a lot of good answers here about what they found interesting in Chem 1, what they found frustrating. Actually, I think this year I got some of the most thoughtful answers from these kids that I've ever seen. So that was really encouraging. I explained things like, here we see a fracking operation. And fracking is, of course, the drilling down to layers of natural gas-bearing shales that the gas is locked into those rocks, and you have to fracture the rocks and break them up so that it loosens the gas and the gas can be brought to the surface. Why are we doing this? Because all the easy gas and oil deposits have already been drilled and burned up in our gas tanks. So we have to go to these extremes, apparently, to get more natural gas. Well, the problem is that those cracks in the rocks tend to collapse under their own weight, and we need this hydrofracking fluid that they pump into those cracked rocks to keep the cracks open. It may surprise you to learn that the companies are under no obligation to release data on what's actually in this fluid that they are pumping into the ground. Chemists might be able to figure that out. Another area in chemistry that was important, this guy Claire Patterson right here determined the age of the Earth at 4.6 billion years by radioisotope dating lead and uranium samples in some of the oldest rocks on this planet. He had to keep at it for 6 years because he kept getting contamination in his results. That is a story of true perseverance that I like to point out to the kids, and also the fact that along the way he did manage to get his lab sterilized to the point where he got a good number and good results of his testing of these rocks. But he also discovered that the source of the contamination was the lead additives we were putting in our gas tanks to make our engines run smoother. We were literally poisoning ourselves so that we could have more smooth running engines in our cars, and we no longer do that, in large part because of this man and his determination to get a date for the age of the Earth. Here's a map of Tom's River, which has the Ciba-Geigy, former property here, where they were brewing up aniline dyes to make our clothes bright and pretty and bright colors that would not fade in the wash. Unfortunately, they were dumping a lot of their used chemicals right here on these patches along the north branch of the Tom's River, went down here and contaminated the water pumps that supplied the city, amongst other things. And I point out the fact that tracing the contamination in the river, not quite so easy a job. You can't just take a sample and go, oh, look, there's these aniline dyes in the water. It's from Ciba. Well, the reason is that once those chemicals get in the water, they tend to break apart the molecules, literally. The ball and stick figures that you might have in your mind of molecules break into pieces. But a talented chemist can look at the pieces, the tinker toy pieces that are left, and put them together to figure out at least a starting piece of evidence what chemicals were dumped, and maybe trace that back to the company. And then there's a lot more to this. This comes from the book that came out about 5-6 years ago, titled Tom's River, which tells the long, sordid tale of this pollution in Tom's River and the investigations into the cancer cluster in children that occurred. And finally, maybe they find themselves at the University of Miami studying environmental engineering, which is a lot of chemistry. This is my daughter, Athena, transporting some samples from her lab to another lab for analysis. And it is Miami, so she has an umbrella to protect the samples along the way. And herself, she was studying treated lumber from homes that was discarded in landfills. Unfortunately, the chemicals they used to waterproof and pressure seal the lumber for outdoor decks and patios, over long-term burial, those chemicals tend to leach out into the landfill, and if the landfill is not properly sealed, it gets into the groundwater. So she had done research in the Florida area. She had done research on samples from, I believe, the Dominican Republic and other islands in the Caribbean. And she was able to present this research not only at conventions in New Orleans and Las Vegas, but she traveled to Europe. She had a really exciting time. She was in Belgium and Greece presenting her research, and she is certainly the most well-traveled member of my immediate family, I will tell you that. Okay, I look forward to a great semester with your sons and daughters. Thank you for loaning them to me. I am an empty nester and have been for quite some time, and I will tell you, moms and dads, that does have its plus side. It's a little sad, but you have something to look forward to as well. All right. Thank you very much.